Hello friends, my name is Lekhraj. I am from Mathura, Uttar Pradesh. I have done my basic schooling from Mathura, Uttar Pradesh, and I have done my BTech from IMS Engineering College, Ghaziabad in Information Technology Department. Now I am pursuing MTech from Motilal Nehru National Institute of Technology, Allahabad in Computer Science Department. My hobbies are playing cricket, racing, teaching, etc. In computer science, we can teach operating system, data structure as well as algorithms. This is over from my introduction part. Now I am going to discuss operating system. So teaching schedule of the operating system basically take 50 to 60 hours to complete the syllabus of the operating system. There is teaching schedule. In operating system, basically 5 units. First one is introduction and background part. In second unit, we have to cover process management. In process management, we have to cover process concept. After that, we have covered CPU scheduling. After that, process synchronization. After that, we have to cover deadlock. And last one is threads. Third unit is memory management. In memory management, we have covered RAM chip implementation, and after that we have covered techniques of the memory management. In techniques, first one is paging, multi-level paging, after that inverted paging, segmentation, segmented paging, and last one we have to cover virtual memory. In fourth unit, we have to cover file and device management. Fifth is protection and security. These 5 units cover all the syllabus of the operating system, and for covering these topics, we are following 3 textbooks. One is Kelvin, Second one is modern operating system by A.S. Tannenbaum. Third one is operating system by William Stallings. These are the agenda for the operating system part. So now we are discuss about the what is the first one is introduction and background unit. So we have to discuss with introduction and background unit. So, what is the operating system? Operating system is an interface between user application and computer hardware. We can see with this figure. Operating system, user application. There is computer hardware. In user application may be multiple users, user 1, user 2, maybe multiple. So we can say user operating system is an interface between user application and computer hardware. In operating system, basically we need a system call. Because for every operating system, if we want to attachment with the computer hardware and user application, we need a system call. So what is a system call? System call. System call basically a request made by the user program to the operating system to get any kind of services. We can see with the help of example. If user wants to print hello on monitor screen, so there is main function, some variable x. If we want to print hello at monitor screen. So here operating system basically calls write system call. Internally calls write system call to get attachment with the monitor to print hello. And we can say that operating system is also called as a resource allocator. So resources, what is resources? The resources may be two types. First one is software resources and second one is hardware resources. Resources, hardware resources and software resources. In hardware, maybe device or memory. In software, maybe files. So for operating system, there is two definitions. One is operating system is an interface between user application and computer hardware. Second one is operating system is also called as a resource allocator. Okay. So why we need of operating system? What is the goal of the operating system? we have goal of operating system. The primary goal of the operating system is convenience. Means easy to use. How user can interact with the computer easily. The secondary goal of the operating system is efficiency. Okay. Now we have to discuss types of the operating system. What are the types of the operating system? Operating system may be, first one is batch processing operating system. Maybe multi-programming operating system. Maybe multitasking operating system. Next is multi-processing operating system. And last one is real-time operating system. So we have to discuss one by one. First one, we have to discuss what is the batch processing operating system. So for batch processing operating system, memory, here is memory. There is operating system inside in memory. There may be multiple jobs in the memory. Here is CPU and here is input-output devices. So batch operating system. In the batch operating system, when the job is completed completely, then only another job which are ready for the execution will be scheduled to the CPU. What is the means of that? There is two times. One is CPU time and second one is input-output time. For jobs, any jobs may be in CPU or maybe in IO. So in batch processing operating system, when the job completed completely, means perform both the operation, after that job is completed. So J1 wants to perform CPU operation. So J1 is here from memory to CPU, occupied CPU. After that, J1 wants to perform some IO operation. So input output request. So J1 is here. When the J1 leaving the CPU to perform IO operation, there is no job in CPU. So there is problem in the batch processing operating system. It increase the CPU idleness. Means there is no jobs in CPU, job in IO, but we cannot perform, another job cannot perform the CPU operation. This is the drawbacks of the batch processing operating system. What is the problem with the batch processing operating system? problems with batch processing operating system. First one is increased CPU idleness. Second one is decrease the throughput of the system. So now what is the throughput? The number of jobs completed per unit time is called throughput. Number of jobs completed per unit time is called throughput. So problems with batch operating system is increased CPU idleness, after that decrease the throughput of the system. Now we have to discuss second type of the operating system, which is multi-programming operating system. Multi-programming operating system. In multi-programming operating system, if any job leaves the CPU to perform some IO operation, then another job which are ready for execution will be scheduled to the CPU. If J1 wants to perform some IO operation, J1 performs some IO operation, and if J2 is ready for execution in the ready queue, so J2 is scheduled here to perform some CPU operation. So there is no CPU idleness. It increases the throughput of the system. And it also increased the CPU utilization. Example of the multi-programming operating system may be Unix, Linux, Windows, Mac operating system, etc. So this is done from my side, and in the next lecture we have to discuss another types of operating system. Thank you.